Ever wondered how a dynamo is manufactured? Well, you're in for a treat. The creation of a dynamo is a technical marvel that requires a blend of science, engineering, and artistry. This process is vital across numerous industries, from power generation to automotive manufacturing. We'll explore the journey of a dynamo, from the initial design and planning stages through to the final quality control checks and shipping. We'll delve into the materials used, including copper, iron, and precious metals. Ready to dive into the fascinating world of dynamo manufacturing? Buckle up! Every great product begins with meticulous planning and design, and dynamos are no exception. This stage is the heartbeat of the manufacturing process, where engineers employ advanced software to map out the dynamo's blueprint. From the winding machine to the assembly machine, every component is carefully designed for precision and efficiency. The planning stage ensures that each piece fits perfectly, forming a well-oiled machine. This intricate design becomes the roadmap for the entire production. With a well-crafted plan and design, we now move to the next stage: acquisition of materials. The choice of materials is crucial in shaping the performance of a dynamo. Let's dive into the world of these key components. First off, we have copper. Known for its excellent conductivity, copper is often used in the coil windings, efficiently generating electricity when the coil spins. Next up is iron. This metal forms the core of the dynamo, directing the magnetic field created by the copper coils. Now let's talk about magnets. They're integral to the dynamo's operation, creating the initial magnetic field that the copper coils interact with. Aluminium, lightweight yet sturdy, is typically used for the dynamo's housing, providing a protective shell. Last, but certainly not least, are plastics. These versatile materials are often used in the non-conductive parts of the dynamo, such as the insulation for the copper windings and the outer casing. With the right materials at hand, our dynamo begins to take shape. Now comes the exciting part: manufacturing of the components and their assembly. This is where all the planning and design come to life, transforming raw materials into the intricate components of a dynamo. First, the winding machine gets to work. It carefully wraps copper wire into tight coils, forming the heart of the dynamo, the rotor. This rotor will eventually spin to generate electricity, so precision here is critical. Next, we have the welding machine. It fuses iron and aluminum components together to create the stator, the stationary part of the dynamo that houses the rotor. Welding ensures a robust and durable structure, capable of withstanding high speeds and temperatures. Then comes the lamination machine. It applies thin layers of insulating material to the stator, preventing electrical losses and increasing the efficiency of the dynamo. This process is a perfect blend of art and science, requiring both precision and finesse. Finally, the assembly machine takes center stage. This is where all the individual components come together to form what we recognize as a dynamo. The rotor is placed within the stator, magnets are added, and any additional parts like plastic casings or precious metal contacts are attached. Every component has a specific place and purpose, and the assembly machine ensures they all fit together seamlessly. It's like a giant puzzle where each piece is essential to the final image. Our dynamo is now assembled and ready for the final stages. The final stages of our dynamo manufacturing process are critical for ensuring a top-notch product. This is where testing and quality control come into play. Every dynamo goes through rigorous testing to ensure that it's performing at its absolute best. It's a meticulous process, but it's vital in making sure that every product that leaves our facility is reliable and efficient. Quality control is not just about testing though, it's also about continuously improving the manufacturing process to minimize errors. We analyze every step of the process, looking for areas where we can enhance efficiency and eliminate potential problems. It's a never-ending cycle of improvement, but it's what keeps us at the top of our game. Once testing and quality control are complete, it's time to package our dynamos for their journey to customers around the world. Each dynamo is carefully packed to ensure it arrives in the same top-notch condition it was in when it left our facility. We take great care in selecting the best packaging materials and methods to protect our products. And then comes the shipping. Our dynamos travel across oceans and continents, reaching customers in every corner of the globe. Despite the distance, we ensure that every dynamo arrives on time and in perfect working condition. And there you have it. The journey of a dynamo from a concept to a tangible, functional product. What a journey it has been. Let's take a quick recap. We've delved into the fascinating world of dynamo manufacturing, from the initial stages of design and planning, to the acquisition of materials like copper, iron, and precious metals. We've witnessed the manufacturing and assembly processes, where machines like winders and welders play a key role. Finally, we've seen the rigorous testing, quality control, packaging and shipping steps. Remember, every time you use an appliance that requires a dynamo, you're using a product of intricate design, meticulous planning and careful manufacturing. Until next time, keep exploring.